Hello everybody, welcome into another lesson. So today we are going to talk about infinite geometric series. Now in the last lesson we talked about finite geometric series, where we took the sum of so many terms of a geometric series and got a finite solution. Well, you can do the same with an infinite geometric series if and only if the absolute value of the common ratio is less than 1. If the absolute value of the common ratio is greater than or equal to 1, the series diverges, meaning it's either going to go to infinity or negative infinity in that case. So it would be a divergent series. So let's get into how to solve for an infinite geometric series. And I should say, if you had an infinite arithmetic series, it's always going to diverge because you're usually going up in whole numbers. And eventually it's going to go to infinity or negative infinity. But for an infinite geometric series, you can totally get an answer if the absolute value of the common ratio is less than 1. So to find the sum of an infinite geometric series, you just take your first term and divide it by 1 minus your common ratio. That's going to be for the sum of an infinite geometric series. So let's get started with our first example here. We go from n equals 0 of 1/2 to the n. Alright, so first thing, whenever you have an infinite geometric series, look at your common ratio. The common ratio is 1/2 in this case, right? Well, it's less than 1, so this series will converge. We'll actually have a finite solution. Now, a sub 1 in this case is actually going to be a sub 0. We're starting with the 0th term, so that's going to be 1/2 to the 0 power, which would be 1, right? So to find the sum, we'll take our first term, the a sub 0, that'd be 1 over 1 minus your common ratio of 1/2, which would be 1 over 1/2, which would be 2. So this series will converge to 2, meaning the sum of this infinite geometric series would be 2. And I got more examples here. Alright, so we have the sum of an infinite geometric series from n equals 0 to infinity of 3 times a quantity of 2/3 to the n. So we're starting with the 0th term again. Let's find a sub 0. That would be 3 times 2/3 to the 0 power, which would equal 3 times 1, which is 3. So your first term is 3. Now, you have your common ratio of 2/3, which we know 2/3 is less than 1, so this series will converge into a finite answer. So the sum is going to equal your first term of 3 divided by 1 minus your common ratio of 2/3. So that would equal 3 divided by 1/3, which would equal 3 times 3, which equals 9. So this infinite geometric series will converge into an answer of 9. All right. So we have the infinite geometric series from n equals 1 to infinity of the quantity of negative 1/2 to the n minus 1. Well, let's look at our common ratio. The common ratio equals negative 1/2. If you take the absolute value of negative 1/2, you get 1/2, which is less than 1. So this series will converge into a finite answer. Now let's find a sub 1. That's going to be negative 1/2 to the 1 minus 1, which is negative 1/2 to the 0, which is 1. So your first term is 1, so the sum will equal 1 all over 1 minus your common ratio of negative 1/2, which would be 1 all over 1 plus 1/2, which equals 1 over 3/2, which would then have to mean that you'll end up getting 2/3. So this series will converge into an answer of 2/3. That would be the sum of this infinite geometric series would be 2/3. All right, we go from n equals 0 to infinity of 2/7 times the quantity of 2 to the n. Well, let's look at our common ratio. What's our common ratio? That equals 2. 2 is definitely greater than 1, so this series diverges. It has no finite solution. It's going to converge to infinity, or it's going to diverge. So there is no sum. This series actually diverges because your common ratio is greater than 1. So that one had no solution there, it just diverges. Now let's go from, again, let's do n equals 0 to infinity, this time of 4 times the quantity of 1/4 to the n. So we're going to go from the 0th term to infinity, find the sum of this series. Well, what's your common ratio? It's going to be 1/4. So if your common ratio is 1/4, that means it's less than 1, so this series will converge into a finite answer. So let's find a sub 0. That's going to equal 4 times 1/4 to the 0 power, which would be 4 times 1, which is 4. So your first term is 4. Now let's find the sum. So that would equal 4 all over 1 minus your common ratio of 1/4. So that's going to equal 4 all over 3/4, which would equal 4 times 1 times 4 over 3, which would converge to 16/3, or 5 1/3, however you choose to write this. The sum would converge into 16/3, or 5 1/3, however you'd like to write that. Whoops, did not mean to do that. I kicked my stand here. Man, I hate when I do that. Hold on. I bumped it. Sorry, guys. There we go. I'm back. Now, we have the sum from n equals 1 to infinity of this time. We have 1/10 to the n minus 1. So we have the infinite geometric series of 1/10 to the n minus 1. Well, look at your common ratio. That's 1/10, right? The common ratio is 1/10. Now let's find a sub 1. Well, that's easy because we have a 1 outside of the common ratio, so your a sub 1 is 1. So your sum would equal your a sub 1, which is 1 all over 1 minus your common ratio of 1/10, which would end up giving you 1 over 9/10, which would converge into 10/9, or 1 and 1/9. That would be the sum of this infinite geometric series. You'll get 10/9, or 1 and 1/9, however you choose to write it. All right, now what about this one? We go from n equals 0 to infinity of 2 times the quantity of 6/5 to the n power. Well, look at your common ratio. Your common ratio is 6/5. Well, 6/5 is greater than 1, right? So this series is going to diverge. This series diverges, meaning it has no finite answer. It will go to infinity, so it diverges. So with infinite geometric series, always start with your common ratio. Now, what if we had n equals 0 to infinity of 4 times 3/7 to the n? So we have 4 times 3/7 to the n. Well, what's your common ratio? That's 3/7, right? Which is less than 1, so this series is actually going to converge to a finite answer. Your a sub 1, or in this case a sub 0, actually is going to be 4. So now to find the sum, it's going to be the a sub 0, which is 4, all over 1 minus your common ratio of 3/7. So this would equal 4 all over 4/7, which would equal 4 all over 1 times 7/4, which would converge to 7. So the answer to this infinite geometric series, the sum would converge to 7. All right. Go from n equals 0 to infinity. See if this is anything important. Of, let's see, -1/8 times -1/2 to the n. So we have the infinite geometric series, the sum of that of -1/8 times -1/2 to the n. Look at your common ratio. Your common ratio is -1/2. Well, if you take the absolute value of -1/2, it's 1/2, which is less than 1, right? So this series will converge into a finite answer. Now your a sub 0 term is going to be -1/8. So let's go ahead and find the sum. That's going to equal your first term of -1/8 all over 1 minus your common ratio of -1/2. So this is going to equal -1/8 all over 1 plus 1/2. So that would equal -1/8 all over 3/2, which would equal -1/8 times 2 over 3, which would equal -1/12. So this series will converge into an answer of -1/12. All right. Sum from n equals 1 to infinity of, whoops, I forgot the 1 there, of 1/2 times the quantity of -2/5 to the n minus 1. So let's look for our common ratio. the common ratio is negative 2/5. If you take the absolute value of negative 2/5, you get positive 2/5, which is less than 1. So this series will converge into a finite answer. Now your a sub 1 is going to be 1/2. That's your first term. So let's go ahead and find the sum. The sum would equal to a sub 1, which is 1/2, all over 1 minus your common ratio of negative 2/5, which is going to equal 1/2 all over 1 plus 2/5, which is going to equal 1/2 all over 7/5, which would be 1/2 times 5/7, which would turn into 5/14. So this series will converge to an answer of positive 5/14. That's what you would get. All right. N equals 0 to infinity. We'll find that infinite sum of 1/12 times negative 3/25 to the n. So we have the infinite geometric series, the sum of that of 1/2 times the quantity of negative 3/25 to the n. Well, what's your common ratio? The common ratio is negative 3/25. The absolute value of that is positive 3/25, which is less than 1. So this series will converge to a finite answer. Now we're starting with our 0th term. A sub 0 would be 1/2. So now we can find the sum. Put in that a sub 0 in the numerator. That would be 1/2 all over 1 minus your common ratio of negative 3/25. So that's going to equal 1/2 all over 1 plus 3/25, which would equal 1/2 all over 28/25. Now we can invert and multiply. You'll get 1/2 times 25/28, which means your sum would become 25/56. So the sum of this series is 25 over 56. All right. We're going to go from n equals 1 to infinity of the negative of the quantity of negative 2/11 to the n minus 1. Well, let's look at this series here. What's your common ratio? The common ratio is negative 2/11. Take the absolute value of negative 2/11 as positive 2/11, which is less than 1. So this series will converge to a finite answer. Now find your a sub 1. That would just be negative 1 because you have a negative sign outside the parentheses. So a sub 1 is negative 1. Now we can find the sum. That's going to equal your a sub 1, which is negative 1, all over 1 minus your common ratio of negative 2/11. So that's going to equal negative 1 all over 1 plus 2/11. So that's going to equal negative 1 all over 13/11, which would make this converge into negative 11/13. So the sum of this particular infinite geometric series would be negative 11/13. Now let's change it up a bit here. We're going to try to find the common ratio. So we're given that the sum of a particular infinite geometric series is 4 and the first term is 1. We need to find the common ratio. So if your sum is 4, that's going to equal your a sub 1 of 1 all over 1 minus your common ratio, right? So multiply both sides by 1 minus r, you'll get 4 times 1 minus r is equal to 1. So you get 4 minus 4r equals 1, which would give you that 4r would equal 3. So your common ratio in this case would be 3/4. So you should get a common ratio of 3/4 to get a sum of 4 for this infinite geometric sequence. Infinite geometric series, excuse me. So yeah, that's actually not too bad to do either. Now, this time, the sum is 10, and your first term is 1. So you're going to set 10 equal to 1 all over 1 minus r. We're going to solve for r to find your common ratio for this infinite geometric series. So this would turn into 10 times 1 minus r equals 1. You get 10 minus 10r equals 1, which would give you 10r equals 9, meaning your common ratio would be 9/10. So the common ratio of this infinite geometric series would be 9/10. All right. The sum of this infinite geometric series is 12, and your first term is 3. Alright, so the sum of this infinite geometric series is 12, your first term is 3. So let's plug this into the formula. 12 would equal 3 all over 1 minus r. So this would turn into 12 times 1 minus r equals 3. So 12 minus 12r equals 3. Then 12r equals 9. Which means r would equal 3/4. So the common ratio for this infinite geometric series would be 3/4. Alright, the sum of this infinite geometric series is 8. Your first term is 2. So 8 would equal 2 all over 1 minus r. So this would turn into 8 times 1 minus r is equal to 2. So 8 minus 8r equals 2. So 8r equals 6. And then r would equal 3/4. So your common ratio for this infinite geometric series also equals 3/4. This time the sum equals 6 and your first term is still 2. So 6 would equal 2 all over 1 minus r. So this will turn into 6 times 1 minus r equals 2. So 6 minus 6r equals 2. So 6r equals 4, which gives you that the common ratio r is 2/3. So for this infinite geometric series, the common ratio would in fact be 2/3. Alright, now this one, the sum is 50, and your first term is 4. So the sum of this infinite geometric series is 50, your first term is 4. So this will become 50 equals 4 all over 1 minus r. So this will turn into 50 times 1 minus r equals 4. So 50 minus 50r equals 4. So 50r would equal 46. So r would end up equaling 23/25. So the common ratio for this series would in fact be 23/25. Only got a few more, then we're done with the lesson. Three more. All right, so the sum of this series is -1/9. Your first term is -1/6. So the sum of this series is -1/9. Your first term is -1/6. Well, let's plug this in. So -1/9 would equal -1/6 all over 1 minus r. So this will turn into -1/9 times 1 minus r equals -1/6. So -1/9 plus 1/9 r equals -1/6, which would give you 1/9 r equals -1/6 plus 1/9. So this could become 1/9 r equals -3/18 plus 2/18, which would give you 1/9 r equals -1/18. So r would just equal -1/2. So the common ratio for this infinite geometric series is -1/2 when you solve for r. Alright, the sum of this series is -11/13. Your first term is -1. So let's find the common ratio. So -11/13 equals -1 over 1 minus r. So this will turn into -11/13 times 1 minus r equals -1. So -11/13 plus 11/13 r would equal -1. So 11/13 r is going to end up equaling -2/13. So let's see, 11r would equal -2, meaning your common ratio of r would be -2/11. So you get a common ratio of -2/11 for this infinite geometric series. One more problem, then we're done with the lesson. The sum is 2 2/9, and the first term is 4. So the sum of this is 2 2/9, and the first term is 4. So we'll set that 2 2/9 equal to that 4 over 1 minus r. Well, let's simplify 2 2/9. Well, let's convert this mixed number into an improper fraction. Wouldn't that be 20/9 equals 4 over 1 minus r? Which actually we can use proportions now to solve for this. You can get 20 times 1 minus r is equal to 36. So 20 minus 20r equals 36. So then 20r would equal negative 16. So r would equal negative 4/5. So the common ratio of this series would in fact be negative 4/5. So that's it for this lesson. We have the next lesson, which will be the last lesson of the sequence and series unit, which is going to be about recursive formulas for sequences. So up till now, we've been dealing with what's called explicit formulas for sequences, which relates the first term of the sequence to all other terms of the sequence. Recursive terms seek to take one term and relate it to the next term. So I hope everyone has a great day. Take care.